This lesson goes over parabolas looked at from a geometric approach. So we're not so much thinking about functions here as equations and what they look like when we graph them. I do recommend that you look in your book on page 464 because the pictures there are more accurate and therefore probably more helpful than the ones I draw here. I do also want you to know that I'm going to cover this in slightly different way than the book, so I pretty much just want you to look at the pictures in the book because they're better than mine. In a nutshell, the definition or locus of a parabola is that the distance on any point to the focus is equal to the distance of that point to the directrix, and that's always measured perpendicular. The vertex is halfway between. That should be pretty clear visually, but again, every point on the parabola should meet the condition that the distance to the focus is equal to the distance to the directrix. Now, without going into all the details of the mathematics behind this, I'm going to give you the equation for this parabola. Hang on, I want to look at my notes, make sure I get this right. If the parabola is pointing up, like this one, then its equation is 4p y minus k equals x minus h quantity squared. Again, I'll explain in more detail during class where this comes from. For now, hk is the vertex, and this p, you might be wondering what's p. Well, p is the distance from the vertex to the focus. Okay, so again, in class, we can look in more detail at why it comes out that way, but for now, anytime a parabola is opening up or down, its equation can be thought of like this. If it's opening downward, p is going to be negative. Okay, now let's look at one that's aligned horizontally. This one is opening to the right. Essentially, the role of x and y get reversed here. So now it's 4p x minus h equals y minus k squared. Now the y is squared, not the x. Again, the vertex is hk, and again, p represents this distance from the vertex to the focus. And if p is positive, the focus is to the right of the vertex, and the parabola will open to the right. If p happens to be negative, then the focus would actually be to the left of the vertex. You'll see an example like that shortly. Okay, so here's what you need to be able to do. If I give an equation of a parabola, you need to be able to graph it as well as locate the directrix and focus. So right off the bat, hk here, well remember h comes from the x and k comes from the y, and it's that same opposite thing that we've seen many times this year. So the vertex is -2, +3. So -2, +1, 2, 3. And since the x is the variable that's squared, this one's going to be vertically aligned. And this number right here, 8, that's your 4p. So if 4p is 8, that tells us that p is 2, which means that the focus should be 2 units away from the vertex, and its coordinates are -2, and then 1, 2, 3, we went up 2 more, 4, 5. So there's your focus. And your directrix should also be 2 units away, but in the other direction. So the directrix, I don't know why it's usually drawn with a dotted line, I guess so you know it's not really part of the parabola. So the directrix is right here. It's a horizontal line. Its equation is y equals 1. Once that much is drawn, then you just sketch your parabola as neatly as you can. Notice that the focus always sits inside the parabola, and the directrix is always outside. Okay, next example. This time, notice that the y is squared, so this one's going to be horizontally aligned, not vertically, so it'll open either left or right. The vertex, well, h comes from x plus 5, so h is negative 5, k is negative 2. So negative 1, 2, 3, 4, 5, negative 2. So here's our vertex. And then this number is 4p. So 4p is negative 10, which means p is negative 10 fourths or negative 5 halves. I know a lot of you prefer decimals, negative 2.5. So that means that the focus is negative 2.5 units from the vertex. And since it's negative, I need to move to the left, 1, 2. Again, I know that this is horizontally aligned because the y is squared, not the x. So there's my focus at, let's see, 1, 2, 3, 4, 5, 6, 7.5. Negative 7.5, comma, negative 2. And then my directrix should be 1, 2.5 units the other direction. So I'll draw a dotted line in here. And then the equation of the directrix is going to be x equals, because it's a vertical line, 1, 2.5, negative 2.5. And then once those are drawn, I'm just going to sketch my parabola. And I'm not expecting that your parabolas will be perfectly graphed, but I do want you to be accurate with your focus as well as your directrix. Okay, so for your homework, there's 3 parabolas to sketch, and I also want you to draw the directrix and give its equation as well as plot the focus and write its coordinates. Now, remember, when the x is squared, it's going to be vertically aligned, so it's going to look something like that with the focus inside and the directrix outside. This number 2 is still vertically aligned, but because of this negative, it's going to be pointing downward, and the focus will be inside and the directrix outside. And then this last one, since the y is squared, and this number's positive, it's going to be horizontally aligned. It'll open to the right with a focus inside and a directrix outside. Please do this on graph paper.